All right, guys, welcome back. This is 6.2 chord properties. So chords, remember, are segments inside a circle where the endpoints are on the circle. Let's do a review of what a central angle is. So I'm going to write down some central angles over here. And the reason why we're reviewing this is because sometimes we get confused with what a central angle is and an inscribed angle is. So right here on the left over here, we have angle DOA and angle AOB and angle DOB. So those are three examples of central angles. Over here, we have some angles drawn in this circle that are really not, like this angle here, that little one, that one. I'm not going to really name them down here, but none of those angles, even this angle here and this angle here, none of those angles are central angles. So those are not central angles. So the definition you need to remember is a central angle is an angle with its vertex at the center and the sides are radii. Okay, so like this is a radius and that's a radius, and then its vertex is at the center. Okay. The next type of angle we talked about before is an inscribed angle. So here are some inscribed angles. This one here, which is angle ABC. This angle here and this angle here. There's three inscribed angles here. Angle BCD and angle CDE. Okay. Over here, I'm not going to really list them, but all of these angles here that you see, those are not inscribed angles. Okay. Even angle VWX looks closely like an inscribed angle, but it's not, because it needs to be made up of chords. So here's what an inscribed angle is. An angle whose vertex is on the circle and the sides are chords. Okay, so we're going to keep reviewing what inscribed and central angles are, because those are going to be a big part of these next couple of lessons. All right, so it says chord and central angles / arcs conjecture. So it has, if two chords in a circle are congruent, then, and then there's a couple of different things. So what we want to first start off by drawing is a circle. You can sketch it or use your compass, whatever you want. And then we need two identical chords that are going to be the exact same length. So I'm going to start off just by drawing a chord here. Oopsie. Let's try this again. All right, let's see. So there's one chord, and then I want to make it exactly the same as the other one. So in order to do that, you can either use your ruler or you can use a compass. Okay, so I'm going to use my compass to go make sure that these two chords are identical in size. Okay, so I have the exact size right there. So then what I want to do over here is I'm going to draw just a mark here, put my compass on that mark, and then make an arc right there. So now when I connect that, I have to connect it from that point to that arc right there. Okay, so now I know for sure that these two chords are congruent. This side is equal to that one, okay? So then it talks about how they determine two central angles. So now what we want to do is we want to take our ruler and connect it to the endpoints to create some central angles here. Okay, and so this angle right here, I'm going to highlight in green, this angle and this angle, they're not vertical angles, although they look like they could be. But if you were to measure those two would also be congruent. Okay, so if the two chords are congruent, then they're going to form central angles that are congruent. So where the word right here goes congruent. All right, so one more thing, it says if two chords in a circle are congruent, then their blank are congruent. Okay, so this right here is also referring to their arc. So I want you to highlight these two arcs right here. So from here to there, and this arc right here from there to there. So those two arcs are also going to be congruent because remember their central angles are congruent. And we learned a while back that the central angles, if this one right here, let's just say it looks like about 80 degrees. So if this is a central angle that is 80 degrees, now remember this is also going to be 80. And then you learn that the central angle is the same as its intercepted arc, so that makes this arc out here 80 degrees, and that one as well. Okay, so if two chords in a circle are congruent, then their intercepted arcs are congruent as well. Okay, so if you have these marks on here, this would hopefully help you memorize that. Okay, remember if chords are congruent. If the chords are congruent. All right, let's go try another conjecture. It says a perpendicular to a chord conjecture. The perpendicular from the center of a circle to a chord is the blank of the chord. Okay, so let's go ahead and draw our circle. Again, you can sketch it or you can use your compass. So we have our circle here. And then it says the perpendicular from the center of the circle to a chord. So let's draw a chord in somewhere in here. Now we need it to be perpendicular right here. So in order for it to be perpendicular, I'm going to use my compass to make a perpendicular. So I'm going to come out here. And remember back when you learned how to make a perpendicular, you make an arc so it crosses that twice. Well, we have an arc already there. So all we're going to do is put our compass right here. We're going to make an arc out there and then come place our compass over here without changing it. Put it on that endpoint and make sure it crosses there. And so now get your ruler or a straight edge and connect it out there. And now we have a perfect perpendicular right here. Okay, so put a block right there. All right, so now the question is, it says the perpendicular from the center of a circle to a chord is the blank of the chord. So I want you to look at this right here. I want you to get your measure. You can either get a ruler, or I like to, like I said, use my compass. And watch when I measure from there. See how long that is? And when I swing it around this way, it's the exact same size as that one. Okay, so that means this side right here is congruent to that side right there, which makes this point right here a midpoint. Okay, and so when it's a midpoint, that means it bisects. The chord is the bisector of the chord. So perpendicular from the center of the circle to a chord is the bisector of the chord. So this line right here, that perpendicular bisects the chord. Again, only if it's perpendicular like that, okay? No matter what. So if I draw over here like this, and I have a chord over here and it has that right angle, then you have to now know that this side is congruent to that side. Okay, only if you have the right angle right there. All right, next conjecture. It says the chord distance to the center conjecture. It says two congruent chords in a circle are blank from the center of the circle. So two congruent chords. So let's draw our circle again. And then we have to have two congruent chords. So I'm going to put one congruent chord, or put one chord there. And then we need another congruent chord over here. So remember, we're going to have to make a little mark there. And then we need to get our compass, or you can use the centimeters on your ruler. Okay, because you want to make congruent chords. So I like to measure that right there. Come over here. And make an arc over here. And let's connect these two. Now it talks about the distance from the center. So when you look at the distance from the center, you have to think of the perpendicular distance. So what we need to do now is we need to make those perpendiculars again. So I'm going to put my compass on the end over here. And I'm going to make an arc out there. Come over here and make an arc right there. And then I'm going to connect the center through there. Okay. So I'm going to do the same thing for my other congruent segment over here. So I'm going to put my compass on the end point. I'm going to make an arc out there. Come around on this end point and make that same arc. And we're going to connect from there to there. Okay, so let me make sure this is nice and perfect right here. So now it's asking us to compare the distances from the center to the two congruent chords. So I'm going to place my compass at the center. And then I'm going to go get the distance from there to there. And then I'm going to swing it around this way. Notice they're the same. Okay. So these two chords were congruent. So I'm going to put a little markings here. A, B, C, and D. So AB is congruent to CD because we need two congruent chords. Okay, and then it's asking how the distance from the center is, and this piece was equal to this one. Okay, so whenever you have two congruent chords, they're going to be the same distance from the center. Okay, so they are equidistant or equidistant, however you want to say it, which that means the same distances. So if you want to write that too, you can write that. But these are equidistant from the center of the circle. Okay, now only if, and I'm going to highlight these two chords, only if this chord is congruent to that chord does that mean this is congruent to this. Okay, all right. Next conjecture, perpendicular bisector of a chord. So perpendicular bisector of a chord. So let's go ahead and draw our circle again. And then we want a chord here. So put a chord there. And now it talks about doing a perpendicular bisector. So when I'm looking at making a perpendicular bisector, I'm going to put it at the end. And remember, you make your compass more than halfway. And we are going to make a big arc. And then we're going to go on to the other end. And then we're going to make another big arc. And then with your ruler, you can connect those two. I'm going to get my ruler out. You'll notice that when you connect those two intersection points, what happens, it goes right through the center. Okay, so the perpendicular bisector of the chord passes through the center. So whenever you see a perpendicular bisector, it's going to pass through the center. Okay, so it's kind of like one of the other conjectures. It's just the converse. It's just going a little bit backwards. Okay, and then of course, if it passes through the center, then you should know that this piece right here is congruent to this piece over here. Okay. All right, so let's apply those problems or those conjectures to some problems here. So it's asking us to find the measure of arc Z right here. So a lot of people are going to say, oh, that's 20 degrees because it's 20 over on the other side. Nope. You have to realize that if this chord is congruent to this chord, you should automatically mark its arc congruent to its other arc, okay? So remember, congruent chords mean congruent arcs. So that means that's 128 degrees. Let's get rid of that 20. And then we're going to use 360 rule to get the remaining part. So I'm going to get my calculator. 360 minus 128 minus 128 and minus 20. That leaves Z to be 84 degrees. Okay. All right, next problem, same kind of thing. We got two congruent chords, so that means this arc is congruent to this arc. And then you should realize that this right here passes through the center, so that means this whole piece is 180, which makes the whole entire piece 180. So all I have to do is take 180, subtract 18 degrees, which leaves me 162. And then I'm going to divide that by 2, which means this arc is 81 degrees and that arc is 81 degrees. So if this arc right here is 81 degrees, remember it's the same as its central angle. So angle W is 81 degrees. Over here we have a perpendicular set of segments. So that's important because if this is perpendicular, that means this is congruent to this, and that's congruent to that. Now it does say AB is congruent to CD. That's why I only did one tick mark for each. Okay, it looks like CD could be a little bit longer, but you have to go with what it says right there. And then it says PO is 8. So I'm going to put 8 right here. And then you have to also realize that this segment's congruent to this segment because AB, which let me get my highlighter, AB is congruent to this one. That means they're the same distance away from the center. So that means this piece over here is 8. Okay, so if that's 8, that's 8. And then we have AB is 6. So if AB is 6, that means this piece is 3. That's 3. That means this is 3, and that's 3. And then BD is 7. They gave us that. So the perimeter of BPO QD is 8 plus 8 plus 3 plus 3 plus 7. So 16, 26, 29. So 29 centimeters is that perimeter. Okay, now good thing about this is that they always look like they're drawn to scale. Okay, let's look at, nope, that's it. And those are our 3 examples.